Good morning to my fourth grade scientists. So over the next weeks and possibly months, I'm going to be teaching you remotely, which means that you're going to either see files that you can open or documents that you can read or videos that you can watch, so that I can continue to teach you science during the time that we are not in school. But what I wanted to do was start with a video to just review what we've been learning about electricity. I want to make sure that everybody is caught up, everybody understands how electricity works, how circuits work. I'm going to review how to build a simple circuit, which we did in class, and the difference between an open circuit and a closed circuit. So electricity works in a way so that in order for it to work properly, it has to travel. And I explained to you in class that it works much like magnets that repel each other. That electricity is made up of these little itty bitty particles called electrons, and they have different charges. They have a positive charge and a negative charge, and what's important for you to know about that is that electricity only works when it can travel. And it can only travel, oops, you can't even see this. It travels much like magnets that repel each other. It can only travel in one direction, and it can only travel in a closed circular path, which we call a circuit. And the example that I used with all my classes was that I would walk around the room pretending to be an electron. In some cases, some of you guys joined me, some of you were repelling me. And as long as I was able to continue in that continuous closed path, then the electricity was working fine, because that's what we call a closed circuit. But if the floor were to suddenly open up, I, the electron, would have to stop, because I can't jump over the hole, I can't turn around and go the other direction, because electricity only travels in one way, one direction, right? So if something opens up, if that circuit, that path opens, then the electricity has to stop. It has nowhere to go. So what I did was I walked around the room in a circle, trying to make this so you guys can see it so it doesn't fall off the table. Okay, so I think we got that. So right now, the lights are on in the science room, so that means that the circuit is closed, because the electricity is able to travel in this circular path, in this circuit. If I want to turn the lights off, that means that I have to open the circuit, right? I have to hit the switch, and we learned that, we don't really think about it, but right now there's a closed circuit because the lights are working, the electricity is able to travel. If I want the lights to go off, then I'm going to hit that button and the circuit is somehow going to open up. So now when the electrons get to here, they have nowhere to go, so they have to stop. So that's why the electricity stops, okay? So what I want to do is I want to review how we made the circuit. Where's my battery? Uh-oh. I'm coming. Okay, so here's the battery. So we learned that, you see how there's the plus side of the battery, because electrons have a negative side and a positive side, the two different charges, that a battery has to be put in properly so that the electrons can flow properly. So we know that anytime we put a battery in something, a flashlight, or I don't know, anytime we put a battery in anything, it has like, you can't really see it here, I don't think. It has a little positive sign that tells you which side, which way the battery has to face. So we know that metal is a conductor of electricity, right? So what that means is that metal allows electricity to flow through it, just like metal is a conductor of heat. It allows heat to flow through it, which is why pots and pans get hot, which is why we have to protect ourselves by wearing oven mitts so that we don't burn ourselves if we grab the handle of a pot of boiling water, okay? So metal allows electricity to flow through it. So a circuit is made up, this closed circuit is made up of different pieces put together, all of them where the metal on each piece of the circuit, the metal has to be touching each other so that there's no opening or gap, because otherwise the circuit is open and not closed and the electricity cannot travel. So on any kind of a battery, it has metal on the top, it has metal on the bottom. So when we put this battery inside of our battery holder, there's this metal spring over here, and I don't know if you could tell, but this also is metal. So when we put it in properly, there are no gaps or openings between the battery and the side of the battery holder, okay? So this is one piece of our circuit. The other piece of our circuit, this is where the power comes from. Another piece of our circuit is this cute little itty bitty light bulb that you all worked with. So just to review, this light bulb has metal all around it, and on the very bottom, and all light bulbs are made the same way, on the bottom is metal. And inside is this little metal piece, it's kind of like a loop. It goes like that, and it's called a filament. And the reason that light bulbs stop working sometimes is because the filament, when the light bulb gets old, the filament breaks. So instead of being like a loop for the electricity to travel around, it becomes like two pieces. It breaks and it becomes two pieces. So then when the electricity gets to the top of the filament, usually just goes zoop and continues going, but it gets to the top of the broken filament, and now all of a sudden there's a big gap and it has nowhere to go. So that's why at a point we have to replace light bulbs, because electricity can't flow through them anymore. The circuit will no longer be closed. So we take this light bulb that has the metal at the bottom, and we put it in this little holder, this little light bulb holder. And right here is this hole, and you could see that it's like a plastic base, but everything else on here is metal. So what we do is we screw it in. Hello. Okay, so we screw it in. And I made it a real point in class to show you that the bottom of this light bulb that's metal has to meet this middle plate. If there's like, and I can't really do it so you can see, I don't think, but yeah, there we go. If there's any kind of like hole or opening, that's going to cause the circuit to be open, and we know that the electricity can't flow if that happens. So it has to be really right against that metal plate. So we have our two pieces of the circuit. We have the battery in the battery holder. This is where the power comes from. We have the light bulb in the light bulb holder. This is what needs the power. And in order to connect the two, we have our wires. And we know that wires are made of metal because metal conducts the electricity. We also know that wires that we touch, wires in the wall are just metal because we don't ever touch them, but wires that we touch are covered with some kind of protective coating. I believe that it's usually rubber, and that's called an insulator. It insulates us or protects us from the electricity so that we're not going to get zapped by it if we touch it. Okay, so you'll remember that each side has these little metal alligator clips, and they're called alligator clips because they look like little alligator heads, I guess, like alligator jaws that open. So what we do is we take one of the wires and metal to metal on this side of the battery holder. Get that out of the way. Same alligator clip, metal to metal on this side of the light bulb holder. Okay, so it looks like this. Clearly, this is not a closed path. This is not a closed circuit, which is why the light bulb is not lit up. So what we have to do is close it up by adding another alligator clip, or another wire, I should say. So on the other side of the battery holder, right? So now there's a wire on each side of the battery holder. Now, if I've done this correctly, when I hook this up to this last metal piece, the light bulb should light because that will close my circuit. Are you ready? Drum roll, make your own drum roll. And okay, so it's not lighting up. There we go. It was not all the way touching. See, there was a little gap between the bottom of the light bulb and that metal plate. That's all it takes. I don't even know if you could see that it's lit. It's not a very strong light bulb. See how it's lit now? And if I detach this, the circuit opens, the light goes out, I put this back on, and now the power is able to flow. The electricity can flow in this closed circuit, okay?